This conference will now be recorded.
I've just downloaded the last two meetings that I had, the one in September and the one in January. And I'm going to upload them onto a YouTube channel and put them up there for if anyone wants to watch previous episodes or previous meetings.
Awesome.
So I'll put that all together the next day or two. Well, I think I'll hand you over there then, Dan.
Ready when you are.
Yeah. So tonight's meeting, we're going to have Dan speaking to us. Tips from tech support. Dan used to work in tech support, so he's heard a lot of your cries and has a couple of tips for those cries, which is fantastic. Followed by Danielle Boyer and Rob Maldonado about what design teaches us. Two very, very, very interesting people that have great stories about design and are very, very passionate about the community and that. And then we're going to have a quiz where you can win a voucher for $25. That's just the value, $25. When you receive the voucher, if you win, you can select what store or what website you want to claim that $25 voucher for, whether it's Amazon or M&S or in any kind of store that's local to you. It's an international voucher essentially. So that's quite, with in-person meetings, we usually do giveaways of cool t-shirts and stuff, and usually like an Amazon Echo or something like that. But as we all virtual, we can't give away stuff. But Dan, he's managed to arrange that we can give away vouchers now. For those that don't know, Dan manages every single user group around the world. He's the big boss man. He tells me what I can and can't do, even though I do it anyway.
I was gonna say, I feel like that goes the other way around. You tell me what I can do, Kirby.
Yeah, let me swing it over to you, Dan, to present.
Awesome. Okie dokie. And I think we also have Theodore representing our awesome user group from Greece, the Hellenic SolidWorks user group. So I think we can double the cards, Kirby. I think we'll pick the top two from the competition here, the trivia game, and we'll send those cards out. So, all right. So thanks for having me, Kirby. First and foremost, I love doing technical presentations, and specifically to user groups. I'll tell you a little bit more about myself here in just a second, but I always thought about user groups as like a really low stress, great chance to try technical material or to practice presenting technical material. Because a lot of times, if you're a person who's presenting this material, you use SolidWorks at your work, or you work for a SolidWorks reseller, or you're prepping a presentation for SolidWorks World or 3D Experience World. Those are all pretty high stress environments, high stress scenarios where you're doing those presentations. Where a user group, this should be relaxed. This should be low stress. It's a great place to just kind of try some material and put together some things that you think people might really enjoy seeing, without all of those higher stress things on the line. And that's really was the inspiration. That really was the inspiration for this presentation when I first put it together. So as Kirby mentioned, I'm the manager of the SolidWorks User Group Network for SolidWorks, for Dassault Systems SolidWorks. But prior to this role, prior to managing the user groups around the world, I spent the bulk of my time in tech support, actually at a reseller. I'm on the East Coast of the U.S. I went to Temple University here in Philadelphia on the East Coast of the U.S. And I joined a reseller directly out of Temple, spent about 12 years at that reseller collectively. And it was a series of acquisitions. So I worked for a reseller that was acquired by another SolidWorks reseller that was then acquired by another SolidWorks reseller. So by the time I actually left the reseller space last year, I was working for the biggest reseller here in the US. It was a really big company with a really large technical support team. Through this whole time, I of course earned my Certified SolidWorks Expert, among other certifications, and thousands of support cases and hundreds of SolidWorks classes taught. So much like any other SolidWorks application engineer, that's the term we would use for that title. The bulk of that time is doing tech support and teaching SolidWorks classes. Along the way, I started to manage the tech support team. So I managed tech support from 2013 up until I left last year, and that was really nice because not only could I get deeply involved with doing tech support myself, but I also got to help newer folks, help other team members develop their technical skills and get them up to speed as well. So I really enjoyed doing that. And for me, I was a regular presenter at my local user group to me here in the Pennsylvania, Philadelphia area. And I would, again, use those presentations or use those interactions as almost like practice or a proving ground for material before you try and take it and present it at the World Conference, at 3D Experience World or SolidWorks World. And again, I always love presenting at a user group and just kind of being a part of that environment. Other than SolidWorks desktop, right, the traditional product that we all know and love, I also spent a considerable amount of time with SolidWorks Composer, SolidWorks Inspection, and SolidWorks PDM. So if you have questions about any of those specific tools, I also have a lot of experience in those, and I still love talking about them. So the whole inspiration for this presentation was all of this experience. I always got to see kind of the craziest cases or the most interesting technical support cases. And I would always certainly take notice to things that came up often or things that were obscure and things that you just say, hey, I need to know the answer to that next time it comes up, right? But I'm actually kind of pleading for help at this moment because I'm not in tech support anymore. I'm working with the user groups. I'm working with Kirby and with Johnny and with Theodore here, and with Vasilia I see that just joined as well, managing user groups. So I'm disconnected from that stream of awesome technical support cases. So when you're using SolidWorks, when you're coming across something that you think is interesting, please send it to me. I would love to take a look at it, and I would love to even include it in this presentation moving forward. This presentation did evolve for me over 3 years or so. I would kind of take things out and put new things in, and I still kind of do that depending on the time. But if you come across something interesting, send it over to me. I'd love to see it. All right, let's get right into it. I want to make the best use of our time here. So I'm going to do this in almost like a question and answer format, going through every question, telling you what the initial question was, what the answer was, and then how we got there. And right away, we're going to jump into simulation, right? And that's another thing about this presentation is it's all over the place. It's not on any one topic. We're going to jump in and out of a lot of different individual things here. This was interesting. This was a customer calling into support and saying, why do my deformation results look the same regardless of applied stress? And what do they mean by that? Here in SolidWorks, this is basically the screen that opens when I call the customer or the customer calls me and we get on a screen sharing session. And right away, as a technical support person or someone who knows SolidWorks very well, your first observation is, well, they're not using SolidWorks simulation. They're actually using Simulation Express. So I'll zoom in here just so we can see that. And as a newer SolidWorks user, you might not even know the difference. You might not even know that there is a difference between Simulation Express and full-blown SolidWorks simulation. Okay, first observation, right? And you kind of start checking those things off on a list as you're working through a technical support case. So the customer's question was, hey, I notice, I see this displacement. I see how this aluminum, and this is an example file, by the way, right? It's not their file. I see how this part deforms. I see how much it's bending when I applied 100 pounds at the very top of this post. So the customer's question was, when I increase that to, if I double the force or triple the force, right, that's being applied to this face, and we rerun this study, and this is a really simple example, so it runs very fast. Why does that not change? That's the question. The customer's saying, I just tripled the force on that or whatever, and this is an aluminum rod. I should see that bend or deflect or deform a whole lot more. So again, as a technical support person, you need to have a base level understanding of all your options and what's available to you in simulation and what might be causing this. And to the untrained eye, yeah, this looks like nothing changed. It looks like it's deforming the exact same amount. But let's revert back here and just change this back to 100 pounds, and then I think we'll take note of a certain value here. So we'll say yes, that's deforming as I would expect, and I'm going to change this back to 100 pounds. We'll rerun this again. This is a really simple study, so this runs really fast here. What simulation does, I'm going to zoom in so we can see this, is it uses something called deformation scale. And deformation scale means it's going to scale up that movement so you can see it, because normally a simulation, the movement is so small. The movement could be so small that you might not even be able to see it with your eye on the screen. So simulation will multiply that movement so you can see it, and you can determine if it's moving as you would expect, if it's deforming as you would expect. And I'm simplifying the answer here a little bit, but the real answer to the customer was deformation scale. Deformation scale is one of the first things you want to become familiar with when you start working with simulation. So I see it's scaling it up almost 5 times, right? 4.7 times, almost 5 times it's increasing this so we can see how it's deforming. So if we change this force, we'll say, yeah, it's deforming as I would expect. I'm going to change this force once again. We'll just bump this back up to 300 pounds. We notice when we rerun this study that deformation scale value drops. Although the model looks like it's deforming the exact same amount to your eye here, to the observer, the scale is actually now only about 1.5. So it's having to exaggerate it way less to show you that same movement. So as a brand new simulation user, as a brand new person kind of dipping their toes into what simulation is, that's one of the first things that can throw you off, is the idea of deformation scale. As a bonus too, as a bonus for this customer, they owned SolidWorks Premium. They already own SolidWorks Premium, so there's no real reason that they needed to use SimExpress. If you own SolidWorks Premium, you can go to add-ins and turn on full-blown SolidWorks simulation and run a true static study. You have full control over deformation scale. You can actually say, don't scale, use the true scale, or scale it way up. Maybe you want to really see the scale change over time. Fun fact, you can't run simulation while you're running SimExpress, so I'm not going to turn it on now, but I found this really interesting, and for me, I think you can take it for granted sometimes as an experienced SolidWorks user that there's still a lot of folks out there who are just getting started with this stuff, or maybe they're just getting started even just with simulation. So if you're just getting started with simulation, take close note of deformation scale, and there's so much interesting information you can gather even just from watching how deformation scale changes when you're deforming a model, which I find pretty interesting. Okay, this is another interesting thing, right? And again, this is how this presentation works. We jump from one kind of interesting topic to another. So I'm going to jump back here into a window, close all. We'll get rid of this simulation example here. And I'm going to use R for recent documents. And we're going to open up this sensor enclosure here that I'm going to use for this next example. So while that's opening, I'll jump back to the slide here. How can we create a standard route that we can reuse again and again? Thank you, SolidWorks. I don't need to see that report. How can we create a standard route that we can reuse again and again and revision manage it in PDM? So this is like a multi-leveled question, and that's again why it struck me, and that's why I included it in this presentation, and that's why I actually did a video on this on YouTube. If you searched, I think this is still on Fisher Unitech's YouTube page, you could find the SolidWorks routing tutorial here and check that out. But it's interesting because it's multi-level, right? So let's kind of break it down a little bit. SolidWorks routing, what does routing allow you to do? If you're not familiar with routing, it's an add-in, so you have to turn it on. So I go up to SolidWorks add-ins, we'll find SolidWorks routing, turn on SolidWorks routing. Routing allows you to quickly drag and drop components into a design, into a electrical, tubing, or piping scenario, and quickly route from one component to the other. So let's just do a quick test here. I'll go into my design library, we'll go to routing, we'll go to electrical, and I'm looking for this RJ45 connector, a typical Ethernet connector. So if I drag and drop that into space here, routing uses mate references, so it starts snapping into place. So as soon as I let go of that component, it begins a new route. That's an action from routing that says as soon as I drop one of these in here, start a new route. So that looks good to me. I'm going to hit green check just to confirm that route. I'll get a little stub off of the end of that, and then I can immediately drop another component if I want to. So I'll go back to my library here. We'll go back to that RJ45 connector, and then we'll drop it right into one of the other ends here. And it will do the same thing. It'll put a little stub on the end of there. And that stub is useful because then I can just click one point to the other and we'll hit green check to complete that route, and we'll exit the sketch, getting a sheet metal rebuild error here, and we'll exit the route itself. So what I usually do when explaining routing is ask the question, how would you do that without routing? You would mate in those two RJ45 connectors and then manually sweep a line, sweep a wire, right? Some sort of sweep from one end to the other. And you could probably do that into a subassembly, probably do that as its own subassembly. So routing, you can do all of those things without routing. Certainly, routing just automates all of those things for you, all those little steps, all those little actions from one to another. Okay, so that's what routing does. So this customer's question was, how do I take that route? We use routes a lot. We have multiple, their scenario was they had multiple boards on a rack with little cables that jump from each level to the other. One cable that just jumps from every rack to the next one. And that cable, if you think about it, is always the same cable. It's the same piece of wire with two connectors, but it's going to be a different shape every time. Every single time, it's going to be a slightly different shape. And we know in Solidworks that if something is a different shape, it is a different part. It has to be a different part. It can't recognize it as the same part. So therein lies the kind of complexity of this question, is how do we get the reproducible, reusable route that we can do over and over again and check the thing into PDM so it's always the same version and everybody's using the same route. So, okay, the first try or the first answer for this was standard cables. Standard cables is close. Standard cables, I think if they weren't using PDM would get most people all the way there. But with standard cables, you can either insert a cable directly from a library here, or you could create a new one. I've already kind of created a test one, same thing, just going from one RJ45 connector to the other. So if I choose that test cable to our library here, I'm simply just going to hit insert cable. And there's something else just to take note of here. You can control the length. So maybe I remember I'll turn this length down maybe to like 600 millimeters. You can also control the diameter. You can control the minimum bend radius, which is really interesting. If when this cable is going around a turn, you can tell routing to not bend the cable past a certain amount. Maybe you know specifications for how tightly this cable can be bent. You can specify that in routing as well. So with those specifications, I'm just kind of doing a sample here, but I'll hit insert cable. And what it does is it just asks you to start placing those components. So this is kind of similar to what I did before, right? I placed one component, and then I can probably even do this without spinning this board around, but I'll place the second component, and then it immediately starts to auto route from one component to the other. If I didn't have this erroring sheet metal part, this would be a lot cleaner. But this is interesting, right? Because I'll hit green check here to complete this auto route. We'll exit this sketch, and then we'll exit this route here as well. This is that 600 millimeter length standard cable. So for this customer, they're saying it has to be the same over and over again. So, okay, we got the connector in there, it's in a library, and this length is always going to be the same. So even when I drop this in, no matter what assembly it is, it'll always keep that length the same. And if it can't reach, if it can't physically reach, it will tell you that the route would actually fail, and it would fail to make that complete connection. So again, we're close here, and this was okay, but the problem is that creates a new route in the assembly. It's not the same route. It's considered a new route in that assembly. So I'm not able to check that new route into PDM. And PDM was the part at the end of this was like, man, this is a tough one. So, okay, the final test then, I'm gonna just hide this route we just made. I'm just gonna reuse those same two connection points. The final trick here, I guess, the final part of this act, there's another function called reuse route. Reuse route is nice because it allows you to pick any existing route. So it's already trying to place that route. I could switch down here and say, nope, not that one. I can keep going down this list to see all existing routes in this list. And I know it's this one. This is the one I already made earlier. You can also, this is the big finisher. This is what worked for me with PDM. You can also browse. So right from here, I can browse into a PDM vault and select that route that was already checked into a PDM vault and use it. So if I'm an electrical designer, all I have to do is hit reuse route, browse in the vault and pick the route I'm looking for. And if I just kind of drop this here, right, I'm just going to drop it in space. It does the same thing that we saw before. It asks to just place these first two components. There's one. I'm going to roll around and then just place the second one here right in space. And then it auto routes from one point to the other, and we'll exit sketch. Still getting those sheet metal errors, and then we'll complete that. So that for the customer and really for me, that was the cleanest option, was reuse route. We'll take any existing route you want and reuse it in your assembly. So I think as a reminder, if you're doing routing and you feel like you're routing the same thing over and over again, there's a lot of options there. There's a lot of ways to reuse the work you've already done there. And even routing on its own, right? Without those automated functions, routing has a lot of cool automation behind it that really is built to save you a bunch of time. All right, question 3. And if there's questions, feel free to throw them in the chat, raise your hand, interrupt me, throw something at me, whatever works for you, no worries here. But I'm gonna jump right into the next question here. So question 3, and this was one that still comes up, and I can't believe it, but it's one of my favorites. Unwanted drawing references, even in PDM. PDM was just kind of an innocent bystander here, but unwanted drawing references. And this is probably something that a few of you have seen before. And if I really just open any old part here, right, we have this small sheet metal enclosure. And I take this small sheet metal enclosure and do something a lot of people probably have done here. I do a make drawing from part. I'm just going to drop this on any old drawing template. Doesn't matter what template it is here. And then we'll just drop in a few views. And I'm just simply trying to make a drawing of this sheet metal enclosure just so we have just a sample to work with here. And expectedly so, if I go to File, Find References, and this is a button I use quite a bit, File, Find References. This, I didn't save this drawing yet, so it's still hitting File Not Found, but it's listing out what this drawing refers to. So of course, it refers to that power enclosure, that power supply enclosure, that one part that we dropped on there. That makes sense. It's just listing that one part. So even beyond this case, this is a great sanity check to make sure that your drawing is referencing the correct part. It lists out where it is and where you can find it, and that all works really well. Here's where it gets interesting. So a customer calls in, says, hey, and I still see this. I'm in 2021 here, SolidWorks 2021, and I can still reproduce this error message. If I'm up at the top, I go to View Palette. This little view palette here, if I grab anything else, so for example, that sensor enclosure that I know I have open in the background, I'm not even going to use it, right? I didn't click on any views, I didn't add anything to the screen, but now I go back to File, Find References. Now there's a whole list of misreferenced parts just because of that view palette. And that's really interesting because like this is a common call because the other part is nowhere on screen. It hasn't been used. It hasn't been dropped onto the screen. And, you know, I think for a lot of people, this might not really be that big of an issue. It's probably something maybe you don't even notice until you go to Pack and Go or you do something else. But if you go to check this into PDM and PDM lists out 50 other parts that aren't supposed to be there, and you try and check this into a vault, that's where it really becomes a big problem. The good news is it's easy to fix. So I just go back to the view palette. With that sensor enclosure picked, you can just hit this X to clear that reference out. I go back to File, Find References, and then those references are gone. So it's a strange little backdoor reference that you wouldn't think would be there, but it definitely is, and definitely something you can watch for. Okay, so question 3, how do we clear those out? The answer was just clearing out that view palette. This is an interesting one, and I think it helped. It actually, you know, some of the things Kirby talks about with printing or designing for 3D printing and some of the other things you might run into with machining. This is an interesting one for me, and it struck me because it's so simple. It's so simplistic that it's just something I wanted to reference here. Let me get SolidWorks back up here. So I'm going to open up another sample part. I use R for reference documents or recent documents quite a bit, and I'm just going to open up this sweep part here. And right away, if I edit this first sweep feature, this is kind of what we do here with these question and answer. I cut right to the answer. What was the answer to this case? This option for merge tangent faces. the customer originally called in, and when you do a brand new sweep, that is off by default. So it would look like this, right? The swept body is just going around a turn. It would look like this with 3 interior faces, and that's fine. That works great, right? The problem you run into is if I then extrude a body up to that second body or up to the next body in space, I get 3 resultant faces on that body. And this is a simplified example. Again, the customer had a much more complex, curvy surface with a feature extruding up to it, but this is the easiest way to reproduce this. And normally this isn't a big deal, right? We know that these are just tangent faces. There's no actual geometry change there. There's just an edge, but maybe it changes your machine paths, or maybe it messes up something with when you're sending this out to 3D printing, you end up with an extra faceted edge there. So I was blown away by this because, again, it's kind of going back to some of the core functions of these commands that you overlook sometimes, is just checking a box. You love that when you can check a single box and fix a problem. Merge tangent faces, green check, and then the resultant faces on this are nice and smooth. You end up with one simple, smooth face. So for me, again, kind of looking back on that case, what struck me was how simple it was. And these cases strike me for different reasons. This one was, man, I love when you can fix something with one single checkbox. Okay, so now we'll change gears a little bit. Any questions so far? Maybe I'll just take a quick pause, check the chat. Any questions at all? Awesome. All right.
Sorry.
Yeah.
No, go ahead. Yeah.
That the case 4 with the merged tangent faces, like I didn't know that exists. That little
Right.
button, and that would have saved me so much time with some models that I made recently.
Sure, and that's the stuff that strikes me. It's like you could spend an hour trying to resurface that or fit spline, do a fit spline and extrude that so it's one smooth face or something. But
I had to match a body to a curved face that had loads of actual faces. If I could just make that one curved surface,
yep.
just one face, it would have saved me about 2 or 3 hours. But
yeah, one checkbox. Yep. Awesome. Thanks, Curry.
Yeah, then there's something I want to get clarified. What is the meaning, or what is this term PDM? I don't really understand it.
Sure.
PDM?
So PDM, Godwin, is product data management, and that's kind of a generic term here. I'll just pull up maybe a website on my other screen here. It's a generic term. It's not unique to just SolidWorks, but SolidWorks actually calls it SolidWorks PDM, product data management. And it's a system that we use, and other tools have PDM systems as well, but it's a system that we use to store and revision files in a secure vault, in a secure vaulted area. So I'll zoom in here, Godwin, just so you can see this, but it's SolidWorks product data management.
Yeah. Great.
Yeah, good question. And I'm actually sorry I kind of glazed over that. I should have referenced that maybe a little bit more specifically.
Yeah,
okay.
Thank you.
Yeah, no problem.
Yeah.
So this next bit is pretty interesting here. And the whole section, or this little piece here, is why is my SolidWorks so slow is kind of the generic part of this. And in tech support, you could imagine that was a very common call, right? Why is my SolidWorks so slow? And I'm putting a caveat on the end of here, even after clearing the registry, updating my graphics card, and I'll just say doing the easy stuff, right? Because there's a lot of easy things, even if I just open up SolidWorks RX here, there's a lot of easy things you can do to make SolidWorks run faster. And normally the easiest of which is to make sure your graphics card is up to date with the latest driver. That's usually the single biggest impact to SolidWorks. The second of which is clearing your registry regularly, maybe every now and then, clearing out your SolidWorks registry. I don't know why this page is coming up for me here. We'll just shift that over here for now. Regularly clearing out your SolidWorks registry to refresh it, right? Those are the easy things, and those are the things we'd recommend on a more regular basis. But we would still get plenty of inbound support cases with doing those things did not make an impact. So what are the more obscure things? What are some other things you could really look at to try and make SolidWorks run faster? And a lot of those answers come in the BIOS. And there's a disclaimer here that not only is the BIOS somewhat of a dangerous area to fiddle around in, but a lot of companies won't even let you do it. A lot of companies that you work for might have your BIOS locked out and you can't even get in there. I was fortunate enough that I could. I probably can't here at DS now. I haven't even tried, but I would just say proceed with caution, and just if you change anything in there, you might want to check with your IT folks before you do that. We'll just put that as a disclaimer. So tip number 1 in the BIOS, this was a big one that impacted even me. I ran into this with a Dell machine. These are pictures from my Dell 7520. You can't do screenshots in the BIOS. It boots up before the operating system. So I'm doing pictures with my phone. And there's an option called Intel Speed Step. Intel Speed Step is a technology that allows the system to dial back processor speed if it detects lower power. So for me, it was a failing power supply. I had a laptop power supply that was going bad and was not delivering full charge to my system. And Intel Speed Step is a power saving function that will just dial back the processor, make it run a lot slower to save on energy. And in most cases, as a CAD person or an engineer, you have your machine plugged in, so this isn't a gigantic concern, but I ran into this with several machines. It wasn't just mine, it was several other machines where this was a direct impact to performance, even outside of SolidWorks. And I think another caveat here is these are simple tests, right? If your machine is running really slow, if SolidWorks is feeling really slow, this is an easy enough test to run and just see, hey, if I turn this off, does it make anything better? Just a simple test we could run. So that was the first really big one. And the second really big one you'd run into in the BIOS is something called switchable graphics. And this is very common with Dell laptops, and I've had it here with, I have a Lenovo laptop now as well. Normally these laptops, most of the higher end workstation laptops will ship with a onboard integrated graphics card. So like a smaller Intel graphics card that's part of the system. And then they'll have a separate dedicated GPU. Typically it's an NVIDIA GPU of some sort. And that's all well and good. And what Windows does is it tries to switch from one card to the other when it detects the need. When it feels the need for higher graphics processing, it switches to that higher end card. And NVIDIA calls that Optimus. That's the name of the technology. Long story short, this doesn't work well with SolidWorks. SolidWorks does not like that switching. It doesn't appreciate it. We'll just say that. SolidWorks does not appreciate that switching. And as a test, right, this could be just another testing function. If you're having a graphic issue, if you're having crashing, if you're having, for me, I was even having scenarios where I couldn't get a second monitor to work. I couldn't get a second monitor to turn on. This is another test you can run. In fact, on newer, I'll open up NVIDIA control panel here. Even on your machine right now, if you have 2 graphics cards and you open up NVIDIA control panel and you go to manage 3D settings here, there would actually, I only have 1 card. I'm lucky on this Lenovo, I only have 1 card. But there would be a second box here where you can pick what program uses what card. So you can actually say when SolidWorks is running, SolidWorks should use the dedicated GPU. I can say that even when setting this, it seemed like it still caused some issues. And I know that's obscure and that seems, not very specific, but as a test, right? The most basic thing you can do is turn this off and see if your problems go away, see if things improve. So those 2 things, Intel Speed Step, switchable graphics, those are 2 BIOS settings that can significantly impact your SolidWorks experience here. Kirby, how am I doing on time? I probably got about 15 minutes or so here.
Yeah, basically.
Okay. So the third little bonus I'll just mention in the BIOS is USB power share. This is not a SolidWorks thing. This just means that if you have your laptop in your bag, if you turn this on, your laptop can charge external devices, which is pretty cool. It turns your laptop into like a big external battery because the USB ports would still be live. Kind of cool. I don't know. It's a bonus. Try it out. Okay, this is a really cool one and something that came up for me quite a bit. Why is my SolidWorks so slow? Part 2. After doing all those things we just talked about, after doing everything, doing the BIOS, doing all those things, what else could it be? I'm still seeing slowness. I'm still seeing crashing. I'm still just, maybe even slow is a bad word here, but I'm still seeing issues. The answer to this one, virtual memory depletion. And what do I mean by that? I'm going to pull up my task manager so we can look at this real time. If I go to my task manager and we choose memory, I'm going to zoom in on this value. I'm apparently only using 11.4 of almost 32 gigs, right? So that's as a first glance here. I'm not using much RAM. I got plenty of free RAM. I'm all set. I should be good to go. But when you take a closer look at this and you really interrogate what's going on in these categories, there's that 11.4 that's being used, right? That 11.3, 11.4, that's the used category. But there's this whole other category that isn't accounted for here called standby. Standby is memory that's promised to every single program when it's opened. So I'm going to open up Resource Monitor, which is an even deeper look into what's going on. And I like to just kind of hover over this column so we can see this description here. This is your committed column or your standby column, same thing. Amount of virtual memory reserved by the operating system for processes in kilobytes. So for every Chrome tab you open, for example, it sets aside another X amount of megabytes or kilobytes of RAM for that program, even if it's not going to use it. I will be the first one to tell you, I don't have a entirely deep understanding of virtual memory, page files, and how all this works together. I can tell you though, that anytime a customer or a machine is out of free memory, so if I jump back here, my free is actually only, just over 3,000 megs here, approaching 4 gigs. Anytime you deplete that completely, like I have in this screenshot here, that's when you run into problems. It's actually ran out of memory to assign to that virtual category. And for a customer calling into support, I'll close this guy here. This little chart is misleading because they're saying, I checked my RAM, my RAM's great, I got tons of RAM. Well, let's take a closer look at it. And I'll mention this program here. There's a program directly from Microsoft called RAM Map. RAM Map is a utility from Microsoft, from systerminals, that actually allows you to clear that out, to purge it. I mean, what's one way to purge it? Just reboot your machine. You can do that, right? RAM Map is from Microsoft. It actually allows you to empty standby list. Proceed with caution with this, right? You don't want to do this when you have a Word doc open that you haven't saved yet or working on anything. Maybe if you don't feel like rebooting your machine, save all your work, close your programs, and empty the standby list as a time saver, or just reboot. You can do that too. So the point of this is, if you feel like you're slow and you've done all these other things, take a close look at the actual memory usage in your machine. All right, so this is my last why is my SolidWorks so slow item here. Why is my SolidWorks so slow after doing all that stuff? I did all the stuff we just talked about. What is one final thing or one more thing we could really do here? So let's just do this live in SolidWorks just to save a moment or two here. I'm going to do a window, close all, get rid of all the files we have open. And a file I use quite a bit for testing is built right into SolidWorks here. If you go to design library, assemblies, mold bases, this mold is in every install of SolidWorks as like a test assembly. I use this quite a bit just to mess around with. So if a customer says we've done all those things and I've gone through those steps with them and we're still having those issues, then I start to really take a close look at the data itself. Like what's going on with these assemblies? Are they slow on my machine? If I take that assembly and open it on my machine, is it also slow there? There's a really great built-in tool to check for that. So if I go to evaluate assembly visualization and we open that up, assembly visualization allows you to sort and color your assembly based on different values. So, for example, what's the highest quantity part? I can see, okay, I have 10 of these pins here, or what's my heaviest part? I can see that these ejector pins are the other way around here. This plate is my heaviest part, right? That's great. They also added, I'll zoom in so we can see this button, this fourth button in here. This button is your performance analysis button. So if you have an assembly open and you do performance analysis in here inside of assembly visualization, I'm throwing a lot of terms at you here. We have that tool open, we got the assembly open. I'm going to turn on performance analysis. It adds total graphics triangles, SW open time, and SW rebuild time. So now I can sort my tree by what's my heaviest part in terms of graphics triangles. And sure enough, I find that it's these guides here. So I like to do this. I could pick that part and do component preview window. And it opens it up over here in this little preview so I can take a close look at it. And okay, it makes sense to me. It's a small part with a lot of edges on it. It even has some curved fillets on it. And there's 6 of them. So every little change here gets multiplied out 6 times. This is a simple example, right? But normally what you would find is you open up an assembly, do this, and you have a part with helical threads in it, or some heavy feature that maybe you didn't know was there. Maybe somebody else modeled this and that component was deep in the assembly. This is a great way you can check for that and find that part that's causing you the most problems. Sometimes it's like that 80-20 rule where 80% of the problems with this assembly may come from just a small pocket, 20% of the parts in it, or maybe even less. So you have total graphics triangles, you have SW open time and SW rebuild time, which are also great. Tell me the part that's taking the longest to rebuild. And more often than not, that part might be the same part as the graphics triangles, or maybe it helps you identify like a corrupt imported part that's just taking forever to rebuild and you didn't realize it was that one particular part. All great things you can find out from this tool, but the number one recommendation here is just if you have an assembly that's a little bit slow for you, open it up, run it through assembly visualization, and turn on that performance mode. Pretty cool. Easy one here, but a common one we would get quite a bit. I've got RX open on my other screen, and the question is, how come RX says I haven't rebooted in, I put 32 days here, that's go joke, 2 days or 3 days or 4 days, right? And for a CAD machine, somebody who's like hammering on SolidWorks every day, I would always say reboot every day. Wipe out that virtual memory that we talked about before. Wipe out all of that stuff you've opened all day and start fresh. Well, believe it or not, with Windows 10, when you just simply shut down, it doesn't actually shut down the machine. It puts it into a quick boot mode by default. And that's by default with every new install of Windows 10. If you hold Shift when you shut down, it will actually do a complete and full shutdown. That is a setting. There is a setting in Windows where you can turn that off. I don't have the setting in front of me right now, but it's just, again, one of those things you just want to be aware of and you want to know about when you're working your machine every day and you're opening a lot of files. And what we saw before with that virtual memory is where that stuff can really start to build up. This is kind of embarrassing. I really have not actually rebooted into over 2 days here, but I promise after this call, I'll go ahead and reboot and get everything cleared out. That's probably why my memory is almost depleted. So, all right. This is a cool one. And again, another simple one. Now we're jumping to sheet metal, right? This presentation is all over the place. We're jumping over to sheet metal now. So how do I place a cut across a bend in a sheet metal file? Because cuts in the flat do not show when they're folded. If I put a cut afterwards, it's not going to show when the part's folded up. And cuts placed before the flat are elongated. They don't look right. So what does that mean? So if I jump back to SolidWorks here, we're going to open up maybe a really simple sheet metal file. This means that if I have a sheet metal part, a really simple bracket, right? Something really simple here, and I flatten this sheet metal part, this cut doesn't look right. It's elongated. It's not a true hole as would be stamped when this part was manufactured. But if I take that hole and place it now, if I place it in the flat, it won't be there when I fold the part back up. So it's kind of a chicken and an egg thing here, right? You got to figure out where to put this cut. So the real answer for sheet metal is an old trick, but it still works really well. It's called unfold and fold. So if I unfold this part, if I fix this face and then I bend this face down, and I'll hit green check here to confirm. And I'm just going to do this really quick. Please forgive me for not fully defining this sketch. Nobody tell my good friend Toby Schnars that I did not fully define this sketch. He's not here, is he, Kirby? I'm not gonna fully define the sketch. So if I do extruded cut with that hole there, one nice thing is it will notice that it's sheet metal, so it will link to thickness, which is nice. You can also do a normal cut with optimizing geometry, which just means it's going to make a really clean cut, a sheet metal cut, keeping nice parallel faces through the part. So I'll do a through all cut and hit green check. Now, when I go back to sheet metal, I can fold that face back up. This is my fixed face. This is my bend to fold. I'm going to green check to complete that. Now that hole is folded in there, and it's actually part of my sheet metal design. So if I flatten it, it is a true circle, even though it's going across a bed. There's not a weird elongated section there. And the other cool thing about that, the way you want to think about those features, I'm going to zoom in so we can see these names here. They just become bookends. They just become bookends for whatever you're putting inside. So it's like you unfold it, you add some features on the inside, and then you fold it again, and those become bookends for those sheet metal features. Really simple tip, but if you're most of the way done a sheet metal part and you got to add a cut or add something across a bend, that unfold and fold trick is great. Just a couple cases here left, Kirby, and then we'll get over to our big contest. This is an interesting one that actually I don't even have a demo file for, but it was a customer calling in and saying, hey, I've got an old library feature. If you're not familiar with SolidWorks, right, I think most of the people on this call are, but you can have library features, right? So if I go to my library and I go to forming tools, for example, and I pull in a lance or some kind of groove here, I'll just bring in this lance and drop it on the part, and we'll hit green check. That's a library feature. I didn't have to model that lance in there. I didn't have to model that feature. It's just part of my library. And that's great for companies that, in this case, this company does castings, and then they have machine features that they just drag and drop onto the casting. They don't have to remodel those features, and that works really well. But they're calling into support and saying, hey, this casting feature has worked for 10 years or more. And now suddenly when we're dragging it in, we're getting rebuild errors in that feature, in my old library feature. Well, the truth is, if we look at this tree, I'm going to just kind of interrogate this tree. And this is an example tree. But when a part is started, maybe there was a bunch of 2009 code that was added, right? When the part was created in 2009, when the first person modeled it, those were 2009 features. Well, when the part is reopened then in 2012, SolidWorks doesn't go back and rebuild those old features. It doesn't recreate those old features in the new code. It stacks the new code on top of the old code. So, okay, that's interesting. That's how we are able to be backwards compatible. That's how we're able to open up older SolidWorks files. Well, you can imagine this issue kind of compounds over years. It's then opened in 2018 and saved, and then opened in 2020 and saved. So by the end of this part's life, maybe 10 years later, it was created in 2009 and opened then in 18 and saved, or maybe even later than that. You could have several years of code stacked on top of each other. And we all know that SolidWorks gets enhanced every year. It gets updated, the code gets optimized, things are released and updated every year. And the truth with this type of thing is, it's my job as a tech support, was my job as a technical support person to troubleshoot this kind of stuff. I'm more than happy to spend hours getting this thing to work and fixing it. But this part is 10 years old. Maybe it makes more sense to recreate it now with the new features we have in 2020. Imagine using a cell phone from 10 years ago, trying to repurpose and use some things that were modeled that long ago. This is no different. So in tech support, sometimes those are very difficult phone calls, because you're going to tell somebody, I'm happy to do this and it's my job. But for you as a customer or a SolidWorks user, it might just be faster to recreate it in the newest version. Do you have an intern or somebody, an engineering intern that can just maybe crank this out and remodel this for you? But it's good to know that if you're placing a lot of faith in old files, those are like everything else. They require maintenance, like your car or other devices, right? I would like to think about library features that you apply a lot of faith in, or a lot of, in this company, placed a lot of R&D and a lot of time into those library features. Take a close look at them and maybe consider updating them after a period of time. I think 10 years is a pretty a pretty reasonable amount of time to say, hey, maybe it's time to remodel that part. Maybe as a side note or a final reminder here, if you have an old part, you can click any one of the planes, for example. So if I go to properties on the plane, you can see when this part was created. This is a new part. I've just created this with a new template, but you can see when this part was first created. So I created this back in November of last year, for example. You can do that with old parts. You can do that with any part you open that was created in SolidWorks. You can check those planes. You can check those first features and see when they were added. All right, this is probably my favorite case in this example, and the question was, why won't my PDFs print correctly? And the answer was certainly a needle in the haystack. And this is one of my favorite experiences in tech support, kind of going through this this example. Kirby, I'll probably finish on this question here just for time's sake. But why won't my PDF files print correctly? So let's take a close look at another assembly here in SolidWorks. And what I've actually done is created another version of that sensor enclosure. So let's say a customer takes an enclosure like this. I take that enclosure and I do the same thing we did before, file, make drawing from part. Make a brand new drawing here. And I'm going to do something pretty similar to before. We'll just drop from maybe from the view palette some of our standard 3 views onto this drawing. And the real question from the customer was, when I print this, either print it to PDF or save it to PDF, it doesn't look right. So the lines are faded. Certain lines are not even there at all. Well, what's going on? So as a new technical, and this is a terrible drawing, but I'm just getting it here, for example, as a technical support person or a new technical support person, that could be a rabbit hole. You could go down that and troubleshoot Adobe. You could be in a PDF troubleshooting scenario. But as you go through these things, you learn, well, the PDF is just a product of the drawing, right? So let's actually take a look at the drawing and see what's going on in the drawing. And right away, when I hover over these views, I notice that little lightning bolt symbol over top of the view. And that's telling me that SolidWorks is forcing this view into draft quality. That happens when SolidWorks detects a problem with the geometry in this view, and it forces it to draft quality so it can rebuild and generate something on screen here. So lesson number 1, if you have any drawings that are doing this, that are showing this little lightning bolt symbol, and you didn't set it like that, it's SolidWorks automatically doing that. The other thing I notice is the board itself also just kind of looks transparent compared to some of the other parts. So, all right, I've got some clues here, but the way you would troubleshoot something like this is keep stepping backwards, go into the assembly and start in the assembly. What's going on with the assembly that it's forcing that drawing view into draft quality? So then when it gets printed, the PDF doesn't look right. And we're stepping back here in time. The way to figure this out is a little painful, and I certainly won't do it here live on the presentation here. But what you want to do is suppress everything, get rid of all the parts, and start bringing them back one at a time. The drawing view will keep updating, and as soon as you see that drawing view toggle into that draft quality, you know, okay, the last part I unsuppressed was the part that's having the issue. So it's basically a process of elimination with your assembly. There's other ways to do it too. You could go the other way. You could start suppressing one part at a time, one assembly at a time, until you narrow down where the problem is. And as a tech support person, this is a big time investment, right? You're doing this for quite a while. I'll save you the trouble and tell you it was just this one little tiny diode, this one little tiny file in this whole assembly. And what I notice about this one little tiny file, I'll just open this up so we can see this individual file. Right away, you open it and say, oh, it's missing a face here. Like there's some obvious geometry issues with this diode. But in a giant assembly, and this wasn't their assembly, they did give me this diode. They were nice enough to say I could keep this diode. It's still broken here in 2021, and I'm going to keep it forever. If anybody wants a broken diode, I can send this to you. But it breaks any assembly I put it in. It's like an infection. No matter what assembly I take it and I put it in, it infects this assembly, and then it affects the drawing. The drawing goes draft quality, and then the PDF won't print correctly. So if you can think about this technical support case, like the initial question is my PDFs won't print, and the end result was a tiny broken diode in a gigantic assembly. that to me was a reminder that don't get lost in the forest, right? We want to see the forest through the trees and find that needle in the haystack and try and work the problem backwards if you can. Always work the problem backwards in SolidWorks. Okay, Kirby, I think that's about it, man. I will pause there for questions, and I'll queue up the quiz if we're all set.
Excellent. That was great. I saw Oscar at some point was quite fascinated by one or two of your things. No, it's quite funny. I saw SolidWorks Facebook page had actually posted this meeting, and one of the first comments that popped up on there, I just want to quickly get it.
Yeah.
Is person commenting was saying your software is not very stable, crashes all the time. So I really hope that gentleman joined tonight, because I'm sure you solved a lot of his problems.
You imagine how many variables there are being Windows-based software, and how many things you got to deal with, and all the things we went through tonight. Any one of those is a left turn that could go anyway, and I think you just learn how to stay stable as much as possible. And credit to SolidWorks for how stable it is in all these environments, you know.
Yeah, it could be a multitude of things that can make it unstable.
Yeah, exactly. That's very true. All right, if you're ready, Kirby, I'm going to launch our big quiz here, unless anybody needs a break or anything.
I'm good. So we're going to do a little quiz for those that have joined late. We're going to do a quiz for a $25 voucher, 2 $25 vouchers. They can be redeemed worldwide. So if you're here in the UK, you can claim it. Once you got the code, you'll get it from either myself or Dan. You can then redeem it on Amazon or whatever store is your favorite. So in order to join, just either on a browser, go to www.kahoot.it, or you can download the app, enter in the game pin, and we can do a very short little SolidWorks quiz for some vouchers.
This will be quick. I have found that the browser works really well. I didn't try the phone yet. You can just do it on your phone in the browser on your phone too, but just go to this address, kahoot.it, and type in this code. It's pretty quick. Johnny's our first guy in.
He was in there real quick. He wants that money.
He does.
So while we're waiting, I can actually chat about Johnny Harrison. Johnny Harrison has just founded the I think Newcastle, North England SolidWorks user group. So if anyone in here is, that's more closer when it comes to in-person meetings, there's now a user group up northeast near Newcastle.
We want to get everybody in here. Rob, Danielle, you can certainly play as well. Okay. I mean, you don't have to, but I just want you to know you can. You're welcome to. While we're waiting here too, Kirby, I wanted to reiterate that I felt like the opening act for Rob and Danielle, because I'm just, just trying some material, just trying this stuff out. So
it's like doing stand up at a late night comedy club for your big act.
Yeah, exactly. Yeah, and I always told newer technical support people or newer AEs at a reseller that same thing. Like, hey, this is your chance just to try stuff out. Get out there, go to a user group event, and just try some things. We'll give everybody just. Is anybody having any problems joining? You can throw a note in the chat if you're having any problems. We got a lot of people in so far. 9 people in. It has some nice music. If you didn't notice, there's some kind of chill music that's playing in here.
Hopefully it doesn't get copyright.
Yeah.
Because the previous 2 meetings that I've hosted, tonight I've uploaded them onto a YouTube channel. I just need to edit the description and get it all finalized. So if you have missed any of the previous meetings or come in late, or if you came in for tonight's meeting, which is already recording, which will also be uploaded up there, you can catch up on some previous meetings as well.
Awesome. All right, I think we'll get rolling. We probably got everybody that wants to play here. So Kirby, if you're ready, I'll get started.
Go for it.
All right. Kahoot. All right, so this is Hey, Goblin, yeah. Okay. When editing a sketch, what does the A key do? When editing a sketch, what does the A key do? If you're fast, you can test this stuff too. I mean, this is like.
I wanted to ask. This game is not for people outside the UK. I'm aware. Like, we don't have Amazon. We don't have.
I think, Godwin, we got a couple seconds left here. Even if
But
you don't
how
have
can
Amazon,
I
I think they'll
receive the
send a
gift?
gift card.
Assuming I win.
All right, we got 4.
Oh,
Wow, okay, we got a mixed result here. Four rights, 4 wrongs. The A key does toggle between tangent or a straight line when you're in a sketch, so that's something you could test pretty quickly. But that's pretty cool. Awesome. All right, next question. So far, Madalci, Oscar in the lead. All right, this is a type answer. What does the G key do in SolidWorks? What does the G key do? You got to type this one out. There's a couple possible answers that will be accepted. There's 3 of them, I think. So what does the G key do? It also goes on speed. So if you enter first, you get more points than the previous folks. That's how Oscar's probably in the lead here. Couple seconds left. Wow, got a lot of answers. And we're going to accept those 4. One person, magnifying glass. And also spelling. Spelling is another thing that comes into play there. So awesome, cool. Next. Let's see. Johnny's got some points. Johnny was the only guy I got that one right. That was great. Nice job, Johnny. What tool allows you to save customizations to the SolidWorks UI and settings? What tool can you use year after year to back up your settings and store those if you want to reinstall SolidWorks, wipe your machine, do that kind of thing, type your answer out? These things you can check. These are things you can check real quick if you're fast. Got 5 answers, 6 answers in so far. All right, let's see. Got wizard tool, copy settings, save. The answer was copy settings wizard is definitely the correct answer there. Let's see who got some points for that one. Madalci again, pulling away with it here. Let's see. Okay, what does FeatureWorks do? Kirby, this is from Adobe. This is the best guy I could get to look as close to you as possible. Not that you look like this guy, but he had a beard.
You could have asked me for a picture.
No, this was better. I wouldn't do this. That's the FeatureWorks icon. What does it do? What does FeatureWorks do? You can just pick here from multiple choice. 6 people got that right. It recreates an imported model using SolidWorks features for the most part, right? There's some caveats there, but that's what it's supposed to do in most cases. All right, okay. We're seeing some movement on the leaderboard here. That's good. Some people, Madalci definitely got some more points. That's awesome. True or false? It is possible to snap to an entity in a sketch without creating a sketch relation. Can you snap to something? Can you align things without it making that automatic relation? And that automatic you're going to see is that yellow, right? That yellow icon indicating it made an automatic relation. 8 people got that right, 1 person wrong. So yeah, it is like, if, for example, if you put a point under a midpoint of a line, you can reference that point, but it won't create a locked relation to it, which is pretty cool. Madalci has a streak with 3 correct answers in a row. Wow, this is going great. Okay, you can only use 3D markup in SolidWorks if you have a touchscreen device. This is a 3D markup I made of that bad diode, right? I'll tell you, this is an enhancement. Wow, that was quick. I don't know why that was so quick, but 9 people, I guess everybody answered that quickly. 9 false answers there. You can use a touchscreen or a non-touchscreen to do that. So maybe I'll just show this image. If you're in SolidWorks, you go to markup in 2020 and 2021, I believe. Might only be 2021, I have to check, but you can just scribble on the screen. So I scribbled this with my mouse. That's kind of nice.
Also,
2020, thank you. Thank you, Madalci. This is nice. I love markup. It's something you can use to share ideas with coworkers and that kind of stuff. All right, just a couple more here. We'll move through these pretty quickly here. What does F9 do in SolidWorks? What does F9 do? Post a screenshot to Instagram. I like that one. Spell check. Hide or show features. Hide or show the command manager. 8 answers.
Who do we speak to about getting a post the screenshot to Instagram button.
I'll get right on that for you, Kirby. All right, so we got a few right answers. The F9 key here does actually hide or show the feature manager, which I will embarrassingly say I didn't know before putting this quiz together. So now I know that. But Elchie's getting some more points.
I'm sure I've pressed it before and it's disappeared. And I'll be like,
yeah, how does that happen? What is the maximum number of recent documents you can display? I was using that recent menu a lot. I was using that quite a lot in this presentation. What's the maximum number you can have in there? Let's see, you got 8 answers in, a couple seconds. Okay, we got 2 people with the right answer. It's 100, believe it or not. You can have a whole lot of recent documents in there if you want to. My brain would probably explode if I tried to keep track of 100 different recent documents. So with a previous question in mind, which 3 keys give you maximum graphics area? I'll give you a hint. It involves a shortcut from a previous question. That kind of narrows it down a little bit. Nice. Got a lot more right answers on that one. F9, F10, and F11 will get rid of most of your toolbars and leave you with a pretty clean screen in SolidWorks. I don't know how you're going to know any of your buttons, but it'll be pretty clean. True, false. All toolbox parts are models with helical threads, but not in the default configuration. So if you open a toolbox part, will it have this helical cut on it? True or false? If you were fast enough, you could open a toolbox part real fast. False. Most people got that right. False. It's not helical cuts. They're mostly just swept cuts on a typical toolbox part there. All right. Melatrinka is on a streak here, which is great. Madulchi's still getting some points, but we're seeing the leaderboard kind of catch up here. How many features, including sketches, are required for this model? Including sketches, how many features would you have to do, including sketches, to create this model? Okay, most people got that right with 4, and it's close. 5 people also said 2. I could see where you might forget the helix, but you do need the helix as well, which is interesting, and the helix first requires that sketch. Madulchi dropped off the top of the leaderboard. Oh no, we'll see what happens here. Okay, what version of SolidWorks saw the updated command manager style that we see today? So in this image here, you can kind of see that old school command manager. This was when it was first released. What year did that happen? Definitely made a lot of waves when it came out. What year did that happen? One person got that right with 08. I guess you're kind of just taking a stab at that one. 2008. Let's see who got some points on that one. Nobody on the leaderboard got points on that one, but that was a big one when that came out. What version of SolidWorks saw the introduction of weldments? When did we get weldments in SolidWorks? 03, 04, 05, or 06? Google. How fast can we Google this?
Take a straight stab in the dark for that one.
Okay, well, we got 2 people got that right. Not terrible. Anybody on the leaderboard? Oh, Madulchi pulling back in the lead with our weldments question. What is the fastest way to model a real 3D thread? Putting a thread on a file in the newest version of SolidWorks, what's the fastest way? This is kind of subjective too, because I feel like Rob or somebody else could probably model that pretty quickly, no matter what method you're using. But thread command, everybody got that one. Most people got that one right with 7 people. Let's check out the leaderboard. Oh, Johnny's on the board now, Kirby. Johnny's made top 5. Congratulations, Johnny. 2 more questions. Who was the SolidWorks CEO in 2015? February 2015, SolidWorks World 2015. Who was the CEO? It was probably Elon Musk at that time. That's what I'm thinking. Soon. Let's see. I think we're waiting on one more answer. Most people got that right with GP. Yay, GP. All right, last question here. This is an easy one. What was your favorite SWGN meeting? This tips and tricks quiz, again, this is subjective. I'll warn you, this is a subjective question. They're all good, hard to pick a favorite. the very first one, or no idea, but Kirby is an awesome group leader. I mean, I guess that could be right no matter what, right? But this last one, I'll warn you, is a little subjective. Yeah, the first one was the answer. This should be your favorite thing, right? So we'll wrap this up. On the podium here, we have John, third place. Mela Trinka, second place, and is this going to be Madalci, first place? Very impressive. So Kirby, I think we'll pick our two front runners here, first place and second place for these gift cards. We just need email addresses for those folks. I'll send you, Kirby. You probably have the form, but I'll send it to you. We just got to get some basic info from those folks.
All right.
And
Yeah, I'll put my email in the chat, and if you just get hold of me, I can then forward it to you.
Awesome.
My email will be at the end of the presentation as well.
Awesome. I went a little long here. Apologize for the delay, but that was a lot of fun. Any thoughts here? Any final questions? Johnny's saying he enjoyed that. Awesome, Johnny. I want to reuse this quiz too. So if you want to have another meeting or you want to get some questions in here, we can certainly do that.
Kirby?
Yes.
I would like to donate my winning if it is possible.
Yeah, if you can do what you want with
If
it.
possible, can you buy some food like in dog shelter or cat shelter in your city for my price?
We could probably do that.
If possible.
Yeah, well, I'll chat with you, Kirby. Maybe there's some way we can make that work. I haven't thought about that, but Kirby, when you accept that card, is there any option like that when you accept the card to pick a cause or something?
I cannot remember.
I can't remember either. I'll ask. You know what, Oscar? I'll ask the vendor. I'll see if there's anything else we could do there. Thank you for the offer.
For the question of the helix.
Yes.
Yeah.
It was just a helix, right? Because I created that with sweep and follow path and one circle. So
Right.
that created two sketch.
Yeah, so you'd have to make the circle, then make the helix, and then make the sweep.
No. When you make a straight line and then make a circle here, you can twist along the path and create it with two.
That's a great point. That's another way you could do it. Yeah, you could twist along path. I guess you're right. This could be a subjective test in that sense, but when you do twist along path, I know you don't get quite the control over the helix as you would if you're doing a helix, but to your point, I agree that could go either way. So Engman, I that's good feedback. I hadn't actually thought about that before.
Dan, also because it is a circular profile, you can check the circular profile and create it during the sweep.
You could do circular profile sweep with sweep along path, right? So then it's only, are you telling me it's only, well, you need a path, right?
Yeah, so it's two, again, sweep and helix.
So if you had a single line and then next to that on like like sweeping, in this case, if it was a circle or something. I'm not defining, everybody, just don't tell anybody. And if this is our path and you do have twist along path, right? Specify twist value. Let's just set this to 80 degrees here. Yeah, so you could definitely do this without a doubt. This is an option. To your point, Theodore, can this also be done without that circle? So if it's just I guess with a circular profile, you can't do a twist. Once you choose circular profile, then you lose that ability to twist. If that makes sense. You know, this would still be one line, one circle, and then a sweep. So would that still be three?
Was the question sketch only?
sketches and features. Sketches and features. Yeah. Yeah, but this is cool though. I agree. This is like another way you could do it. Totally. All right, Kirby. I'm not gonna take up any more time. I know we're going over here, and I want to get to your next presenters, but I appreciate it. Let me make sure I get a screenshot of our winners, and we'll make sure we take care of our winners here one way or another. And that was awesome. Kirby, what'd you think about that? I thought that was pretty cool.
That was good fun. It was quite. What I liked the way that you presented it was you were also showing and teaching a bit. It wasn't just this is the answer. Next one, you gave a bit of information behind it as well, which I think made it it educational.
Awesome. Thank you. Cool.
So next we'll have Rob and Danielle presenting. Who should I hand over the reins to? Rob or Danielle?
To me.
Oh, okay.
Yep, I got the slides.
Yep.
All right.
Awesome presentation, Dan.
Thanks,
Great
Rob.
stuff in there.
Appreciate it.
Yeah, and congrats to Michelle on second place in the quiz. She's one of our board members at the STEAM Connection. So.
Oh, awesome.
Nice.
That's great.
You got smart people with you. So yeah, Danielle and Rob, people that I both met at World. Just two really incredible, awesome people that Danielle does a lot of things for charity and women in engineering. Rob does crazy things with CAD. He's made thousands of models every day. What number are you at?
Well, not every day. He's not.
Oh, yeah.
I think today's 531 consecutive.
Yeah, he's made a model
models.
every day for 531
awesome,
days.
That's insane.
So yeah, well, I'll let you get on with your presentation. And you
Sounds good.
All righty.
Well, hello everyone. Rob and I are so happy to be here today. We're just going to be chatting about our design journeys, what design teaches us, and kind of our paths of starting out how we got interested in engineering, kind of what held us back and how we continue to push forward, as well as some tips and tricks that we've learned along the way. And I'm going to share my screen. Am I allowed to? Okay. I love it when things work. Okay. So, as I said, we're going to be learning about what design teaches us. And these are actually some doodles by myself and my organization, the STEAM Connection. So, we're going to start out with Rob, and he's going to hop into an introduction.
Yeah, of course. So I know many people in here already know who Danielle is. It's kind of hard not to, but for those of you who are out of the loop, she is an educator, inventor, author, as Kirby mentioned, an advocate for women in engineering, and she's been teaching classes ever since she was 10. And I believe you're 20 now, right? Yeah.
Yep.
Yeah. So she's created a lot of project kits for kids that are just so innovative. Namely, Etgar is probably the one but she's been, as we'll get into a little bit later, she's done more robotics kits as well. She's founded the STEAM Connection, which helps children actually receive these kits. Also, she is a mentor to a lot of robotics teams, right? 35, is that correct?
35. I have 934 students, and
yeah. So that.
And two all-girls teams.
And two all-girls teams. That is so awesome. She's self-published, I believe, 6 free books. So yeah, she's just this awesome, kick butt diversity champion. And she's had a couple of features too. Yeah, it's shown there. She was on People magazines for Girls Changing the World. She had a TV special about her too, the Women of Worth, and NBC, that was on NBC. And just very recently, the Winds of Change magazine by ACES. So she's been featured a lot. And then on top of that all, she is an engineering student studying mechanical engineering and mechanical engineering. Electrical and mechanical.
It's a lot. It is a lot.
Mechanical and more mechanical. I'm a mechanical engineer, so I'm biased towards that.
Yeah, you're very biased. I feel like probably most of the people here are mechanical engineers. When they hear electrical engineering, a lot of them are like, oh, never. I'm doing both. It's a lot of fun with robotics in mind, biorobotics. But yeah, I'm going to hop into an introduction for Rob. Thank you for that great intro. So Rob is a mechanical engineer, 3D modeling content creator, and educator. He designs new mechanical systems every single day through his Model of the Day challenge. I don't know if y'all have seen it, but it is amazing. He does a model every single day. You can see some examples here on my screen. And he works to push the capabilities and potential of 3D modeling while promoting education for the young and old alike. His social media influence has helped him bring his creativity and ideas to nearly 48,000 people. And every time I read this bio and every time I introduce Rob, I have to update that number. So he has just been killing it. And he does this through mostly Instagram, YouTube, etc. And I'm sure you've all seen his CADs. I'm sure you guys should check it out. But he is a certified SolidWorks expert and official SolidWorks champion. And I just want to show you his page quickly because he is killing it. He does really crazy models every day. This model yesterday was actually inspired by my magazine cover that I was just on, by my favorite charity, the American Indian Science and Engineering Society. It was a huge honor. But he does amazing models every day. This has to be my most recent favorite. So, yeah.
Isn't it not the funniest thing you've ever seen?
I think it is the funniest thing I've ever seen. I love it. So as I said, today Rob and I are just going to be chatting because I think, we see a lot of presentations and a lot of meetings, especially virtually. I feel like we're to the point where I 100% feel like a video game character. Like I'm just an avatar floating along. And I just wanted to have a casual conversation because I didn't want to just speak at you and, have like a presentation. So it's going to be a casual thing. But yeah, before we begin though, I'm going to split screen so I can actually see myself as I'm talking. So before we begin, I actually wanted to take a minute and talk about some of the things that have been going on in our world. There have been some really beautiful things going on. Like tomorrow is actually Earth Day. I don't know if you all knew this. We've seen a lot of people rally together for environmental change. It's been really awesome. It's also Ramadan right now. It's a beautiful time for Muslims to celebrate and pray and reflect and spend time with their community. But we've also seen a lot of hard things happen right now that affects us all worldwide. Like here in the States, we just finished the trials for Derek Chauvin in that case, and we reached a verdict. In Europe, France specifically, they are trying to ban hijab from schools. So it's been a very hard time, especially for those who are minorities and have experienced these things unheard for a really long time. So we just wanted to say this to encourage you to take the time to extend kindness to others and to think about what you can do to especially uplift Indigenous peoples worldwide during Earth Day tomorrow, your Muslim neighbors and friends and coworkers during Ramadan, and especially your Black neighbors, friends, and coworkers as well, because they're going through a really hard time right now. So just ask how everyone is doing and spread that kindness. I haven't really seen that emphasized enough, and it's really hard seeing everything on the news and knowing what everyone is going through. So I just wanted to bring that up and also to focus on the environment that you're creating for others. Don't be afraid to adjust and improve and ask for when you need help. At the end of our talk today, I'm going to be sharing some resources for us to check out, which I'm looking forward to. Some really cool influencers to follow, especially who are Black and Indigenous, and the work that they're doing is awesome. I'll pass up to Rob.
Yeah. Oh, yeah. No, Danielle, I completely agree with that. And these are very important things to think about. So, I saw that you were gonna share some creators at the end that may benefit for this. So that's gonna be really good. But we're all human beings here, so just like taking a little bit of time out of your day to just be kind to each other is just
it's really important.
It's really important. It's really a good thing. But that aside, let's talk about how we got into design and why at least I'm here, and then Danielle will tell her story. So when I was talking to Danielle yesterday, I told her that I live in South Florida in the United States, and we had a lot of hurricanes the past season, and when the hurricanes came by, it flooded my entire neighborhood. Like a lot of things got destroyed. We had a workshop where I was storing a lot of stuff, many complete losses of like old books that I had. But I was like looking through the workshop that I had just yesterday, and I actually found this book in basically, well, I don't want to say perfect condition, but basically, camera's here, the original shape that I had left it when I was a kid. This is the first book about science that I got when I was like 6 or 7 years old. And as you can see by its condition, like I've slept on this thing a couple times, but I read this thing like you wouldn't believe, and it just, you know, so fascinated me so much of like how you know, how people design things to, like, you know, get to the moon and stuff like that. And just how do you measure nature and, you know, kind of, you know, bend it to your will to do all these amazing things. So, you know, that kind of like got my start with just being interested in math and science in general. I just love reading the little tables there. But yeah, so Danielle, do you have like a similar kind of spark that you experience kind of like that?
Yeah, I like it when you use the word spark because that's literally what happened. I remember when I was like 4 or 5 years old, I decided to decorate a live outlet with metal beads.
Oh, no.
Let's just say I got the shock of my life, and well, it was good because it kind of shocked me into being curious about engineering and electricity. And I know many of your, like, the people on our call, I know many of your engineering work now, but I'm really curious, like, what your engineering spark was. So if you want to share that in the chat, I think that would be really cool. But later, I furthered my interest for engineering by actually playing pranks on my family. And I have a podcast now for kids. And this is their favorite story that I tell. When I was younger, I had just learned how to use a screwdriver. And I would disassemble all of the furniture in the house. It would stick together, and I would wait for my family to step on it, and it would collapse. And I thought it was the funniest thing in the world. And they were like, "Girl, you need to get some Legos." So I would say my engineering journey kind of started then. Luckily, I don't play those types of pranks on people anymore. Maybe I'm a Scorpio. But Rob, I didn't pursue. I think both of us, we didn't pursue our engineering interests for a really long time after we had our first spark. Can you share your journey as like a child in robotics?
Yeah, I think, you know, my specific story, you know, getting into mechanical engineering was preceded by me being in my first robotics team. Go Ninjineers. But I wasn't in my robotics team my whole tenure in high school. So in fact, I tried to join the robotics team when I was in 7th grade. So I was like 13 years old or something like that.
Yeah.
And when I joined and, you know, walked into the club room, I was kind of met with this kind of indifference from the other members. Like, they didn't really care about me being there, and they actually kind of like looked down on me for not being able to do the things you need to do in a robotics team. And it's like, they would ask me, it's like, "Hey, can you wire this up?" I'm like, "I'm sorry, do the what now?" It's like, "What, you never wired a circuit board before? What, were you just born yesterday?" And, you know, just kind of like be like very very condescending to me. And, you know, it was just not a good experience. I tried it for a week, and then I was like, you know, if they're gonna treat me like I'm just in the way, then, you know, maybe I'll find something else to do.
Yeah.
I did not get back into robotics until 5 years later, basically. Senior year of high school, the last year. And actually, this was the point where everyone for the year, if you wanted to get into a club, that deadline had already passed. So it was like 12 weeks into the actual like season. And, you know, one of my friends came up to me, he's like, "Are you free, like, you know, these days after school?" I'm like, "Yeah, sure. Why?" It's like, "We need extra hands on the robotics team." And I'm like, "Well, I didn't submit the form in time." It's like, "Who cares about the stupid form? Just just get to the shop and, you know, and help us out here." And it was there that you know, it was a much more, you know, all the people that I saw before, you know, gone. They graduated, you know, it's a long time ago. But when it was there, it was met with a much more comfortable environment. You know, went there, it's like, you know, I do have some hands-on skills, but, you know, I don't know how to wire a circuit board. And like, "No, we'll teach you. You know, it's not too bad once you get the hang of it, you know." So it's just like really, you know, it's a really good lesson in like how that environment that you create for people really does affect, you know, how they get into that. And it eventually, culminated in me looking at an engineering challenge, and then I'm looking at some scrap pieces on the floor. I was like, if we put that and that together and put like a little screw in there and have it pivot like this, do you think we can actually like push a lever down? Like that was kind of part of the challenge. And I was like, I guess that is. So, my shop teacher mocked it up, and it was actually one of like the best solutions to that challenge in the robotics team that year. And I saw it, and I still get like chills, like thinking about it, just crushing the competition of like, you have to hold down a bridge and get on it and balance, but that was
I
the
love
spark.
that.
And it was that that I knew mechanical engineering for me. And I'll let Danielle tell some of her experience. I know she's experienced some of the same things, right?
Yeah, we've definitely both felt that hostility. And when I've given talks and stuff in the past, I really haven't always shared that. And I think it creates this idea that when you're starting out in engineering, it's not always like there's no hostile environments. And that simply is not the case, unfortunately, which is why, as I was saying before, like our kindness, it really does matter. So I taught my first kindergarten class when I was 10 years old, which is insane saying that. I saw that my sister was really interested in things like science, things like engineering, but our homeschool group at the time didn't provide any classes, especially ones that we could afford. And so I was like, we have to be able to create something better. So I ended up getting, I saw animal puppets at the store one day. And I was like, Mom, what if I taught an animal science class? My sister would be really interested in that. And she was like, dude, you're 10 years old. What do you mean? And I was like, no, listen, wait, I think I can do this. And they pitched at the board. They ended up letting me teach it. And I got a taste for education. And I honestly, I have not stopped yet. But even then, I really didn't see my potential as an engineer or as a designer or as an innovator. I've been told my entire life that girls aren't meant to be engineers. I've heard that from so many people in my life, and it is a really hard thing to contend with because I didn't see role models of women in engineering. I felt very stuck. And I ended up, when I got to public school, which was like the middle of my sophomore year of high school, so a long time later, I joined a robotics team, and I was super, super excited. I was like, oh my gosh, I can finally pursue my interest. I can finally go into robotics. I can do what I like, and I can make, crazy creatures, and I can code and stuff. But I was met with so much anger and hostility, even for asking questions. I'm like, how does this motor work? How do we wire this? Even these questions were met with so much anger by the guys, by the mentors, and it made me want to stop before I'd even started. And it honestly, my students are the people who kept pushing me onward because I was teaching a lot of outreach and stuff at the time, but they're the reasons why I kept going. And so after about a year, I was like, I can't do this anymore. I have to leave. So I joined another robotics team, and I was hoping that it would be different, but it wasn't. I was the only girl upperclassman, and you walked into a room knowing that people were talking about you behind your back, and knowing that people didn't want you there. And it was a really scary experience to have. But Rob and I both have had these difficult experiences. I'm sure many of you listening in have had these experiences as well, where, kind of facing the hardships of engineering. But even through these difficult circumstances, both Rob and I are in engineering, and we now advocate for the kids going through similar things. And I think that's a really beautiful thing. It's a huge reason why Rob and I are both educators. We wanted to give you that background because we don't get to tell people that story very often. Now, we're educators in very different ways, but we want to give others the opportunities that we ourselves did not have. So, Rob, many of us, we've seen your streams and your models of the day. Can you share a bit about your background in engineering, but also in music too? Because I think a lot of people don't know about your music background.
Oh yeah, that's that could be a very long story, but I'll keep it very brief. Of course, after being in my robotics team and then going into into school. So spoiler alert, I do live in the United States, and
Shocker.
people who live, people will know that college in the United States is exorbitantly expensive. I mean, I could talk all day why it shouldn't be, but that's kind of the baseline. And what I always try and recommend to people is like, you know, it's nice to go to, you know, an Ivy League school or a big name school if you get accepted, but, you know, don't go into massive debt over it. I don't think it's worth it. But, you know, one of the most interesting things that happened to me was, you know, I ended up going to Case Western Reserve University, which is in Cleveland, Ohio, great engineering school. But they also, when I was graduating, told me about a music program to apply for a scholarship. So I was like, I play guitar, don't I? Yeah, I got like some guitars there. There they are. But I play guitar. Why don't I just audition? I audition, and they's like, wow, you're really good at guitar. Here's a full tuition scholarship. I'm like, a what now? And yeah,
That is so valuable.
It was the craziest thing where it's like, you know, I was like, you know, what is happening to me right now? And also it's like, oh, but I also want to study engineering. And then they're like, oh, great, because you can just double major as long as you fulfill your music requirements. You'll never get any sleep, but you know, you can do it. I'm like, what's that last part? I'm like, no, nothing. Don't worry about it.
I can hear that.
But that's kind of where my journey. It took a little bit longer than normal because I was basically working on 2 degrees. But you know, it's really cool to like, you know, study mechanical engineering and music. Like some people traditionally think about it as like, you know, right brain, left brain, like technical versus artistic. But
yeah,
I guess, you know, I'll close off with this. Music is more technical than you would expect, and engineering is more artistic than you would expect. Like people like to say that, oh, engineers are boring, they're not creative at all. It's like, no, we engineers are one of the most creative people on the planet. You know, I mean, am I right or am I right? You know, but yeah, that was kind of my journey, and I think that's the important thing is like you got to do what's right for you. You have certain skill sets, and just be bold and chase those, you know.
Yeah, I totally agree.
So, you know, speaking of university, Danielle, you're a student still, right? What year are you in?
Yes. Honestly, I'm taking time off right now, and I take a decent amount of time off, so I'm still like sophomore-ish. So I can just go into a bit of a background because this is the question I always get the most of, like, what are you studying? What university are you at? Because it's a complicated question, I'm not gonna lie. So I'm gonna do a little bit of a background, but Rob and I actually met when I first joined the Solidworks community. I was 17 years old, so a few years ago, and I met Rob at the Solidworks User Advocacy Day. I was speaking at it. It was a lot of fun. I didn't know what I was doing. Nowadays, I speak at least once a week, if not more, and I have some big gigs coming up. I'm like so excited. I was just telling Rob yesterday, but can't contain myself. But I hadn't really spoken much, and so I didn't show up with slides. I didn't even come with the robot that I came to talk about. I was just going along with the flow. But I decided that after I graduated, I was going to take time off to volunteer in my community, mentor youth robotics teams, start youth robotics teams, and learn how to engineer better. And I am very fortunate to have had, the option to be able to do that. But yeah, so now what I'm doing is I'm studying electrical engineering and mechanical engineering, but I'm taking time off to study neurodevelopmental disabilities in children at the University of Vermont. And it's a fellowship, and it has been so cool. It is not my cup of tea, like health and stuff. I'm a total robotics person. My brain thinks in circuits. So it's very different for me, but I want to be a better accessibility advocate for all of my students. And I also want to be a better learner because I have ADHD, and it's been really, really difficult. So I wanted to create something that, a better way of learning for myself. But Rob, we talked a little bit about our roles as educators, and I want to talk about our everyday work now. I know like both of our jobs, they've changed a good deal over the past year, and our careers are pretty unconventional, especially for engineers, and we look at engineering in very different ways. I think sometimes people just see our work but don't really know what we do on a day-to-day basis. So I wanted to have a chance to discover that because hopefully people can get inspired by it. So Rob, what does your work look like, and how do you engage in the design industry beyond maybe CAD model today?
Yeah. So you know, I will say, like, currently I do have like a full-time job that I go to. You know, I'm currently developing like a system to uh, basically convert wind and water energy into usable energy. Can't speak too much about it, but that's one side. But I think the more interesting side is like what I do on my social media. So currently I stream on my YouTube channel 3 times a week. And you know, ever since I started that, it's been so much fun. I know there's a couple people in here that's been to my streams, like, you know, Modelchi, you know, I see you there. What's going on? Congrats on winning the thing. I saw
Congrats.
Raj in here earlier. Sorry, what? Oh.
Oh no, I said congrats.
Oh yeah, congrats. Yeah, for sure. But basically what I like to do, like, I consider myself a SolidWorks generalist. You know, I
I
try
like that.
to, yeah, I try to, I try to be, you know, as inclusive as possible, you know, within the field of mechanical engineering. And that everyone who knows who's studying mechanical engineering, it's very, very broad. So
Yeah.
it's, you know, it's quite challenging to keep up with all the tips and tricks and techniques. Definitely working for a SolidWorks reseller, you know, just like Dan did, you know, Dan does, it was incredibly valuable having all those training manuals, access to all the software. But I think I just got to keep challenging myself every day. And also, I listen to my community. For example, I have a community Discord where people from the virtual flat community can go and, you know, they post questions about stuff. And someone will say, hey, I'm trying to do this thing with weldments, but it's being really weird. I'm like, all right, no, if you're okay with me showing it on stream, you know, I can play with it on stream while I talk about it. And like, yeah, sure, it's just a side project. And then I'll go on stream and poke around, give my thoughts and opinions and stuff like that. Others
Mhm.
is just straight up like, how do you even go about modeling this thing? And it's, you know, kind of the same thing. And it'll be everything from sheet metal and weldments to surfacing and, you know, mold stuff and animations. You know, I got a guy in my community, Yaya, who's really into animations, and he's fantastic about it. So we're always kind of like, you know, he's always taking up challenges and stuff like that. And I look at it, it's like, you know, just being broad is the most difficult part, but it's also the most fun part, I would say.
That's awesome. And I have a bit of a follow-up question.
Yeah,
And
go ahead.
I think this is what everyone's probably going to appreciate the most here. You're constantly designing and working. I know firsthand how busy you are. What does your everyday design setup look like? And do you have any tips for the designers on our call?
Oh, that is really, really good. I would say the most bang for your buck, like there's plenty of things I could say, like, you know, I've heard that space mice are pretty nice, like, you know, the things that you can, you know, twist your model around.
It is so
Pretty easy.
fun. The kids
Yeah,
love it.
very, very fun. Although I don't personally use one, just because I teach and I don't want to get the ideas like, oh, you must buy this thing to be good at SolidWorks. Like, no, you don't. You can just use what
That's a good
comes out of the
mentality to
box.
have.
It's totally fine. But
Accessibility is so important. It really is.
yeah. But if you want to chip in for like a piece of equipment, like right now, I know Yaya makes fun of me. You know, the guy on my community makes fun of me, but I actually run a quadruple monitor display, and it's great. But you don't have to go that far. If you have like a basic laptop, like I did all those years in college, you know, maybe only supports one monitor being plugged in. I would look into getting a widescreen monitor, a 21:9 monitor. I can
Mhm.
find that those are very valuable because due to the wide display, I'm going to see if I can try and turn around my camera without ruining everything in the world. But, you know, this one monitor can effectively act like two. So it's like, what I'll show you here. I gotta think. Oh, that's a
Uh-oh.
So it is broken.
Yeah, it just went bzzz. That's what happened on our live stream. We did one at SolidWorks World this year, and for whatever reason, his camera just stopped working. And he was moderating too, so I just hopped in. That panel was so fun because I got to do it with Aiden Aird and Lucas Krupe, who are young SolidWorks awesome people. But I also got to do it with my mentee, Vinya Gunashaker. She's 13 years old. And it was the first panel she ever spoke at SolidWorks World. And she started out in the SolidWorks app for kids and then jumped to SolidWorks. And we're designing right now a robot that cleans recyclables off of school floors. And it's insane. A 13-year-old is like sketching this out, drawing it in SolidWorks, creating it. She's helping design the circuit. 13 years old. When I was 13 years old, I think I read a lot of novels, but it was really cool to have her there. I don't know if any of y'all attended that, but listening to youth voices, especially in SolidWorks, I think is so important. And
hey, I'm back, guys. Super sorry about that. I thought I had a little bit more slack on the power cable to my camera, and it just.
I do not think you did.
Oh God, but you know the point I was trying to make: 21:9 monitor, effectively like 2 monitors. So if your laptop only.
Were you trying to show everyone?
I was trying to. Yeah, I thought I had and got caught on something and.
Oh, rest in peace. Wait. I think I can show off of my screen because you texted me a picture.
Yeah, that was super goofy. I shouldn't have tried that.
I will just hold it up so you can see. Good luck if you can see anything at all. But here we go. I made a cameo in it, but he's got one widescreen. I run everything off of Dell Precision that runs. It's loud. I don't know what I'm doing to it, but it's like, so I probably need a new setup.
Maybe Dan can give you some tips on how to.
It sounds like some of the bias things, yeah.
It's probably because I also run like SolidWorks and Adobe software at the same time. So that's probably my doing. Well, yeah. Rob, do you want to continue on your monitor chat?
Oh, I think I was just coming to the end of that really. So it's like one piece of equipment, external monitor, you can have SolidWorks and something else, especially if you're trying to do certification exams, like you won't have time to print, the question prompts. So just having them on 2 displays, super helpful. And yeah, that's like my one really nice pick.
Rob, may I ask?
Yeah.
If the most important equipment is your mouse or monitor?
Well,
are you quizzing him? that was a quiz face.
That was a quiz face.
It's like, I know the answer, but I'm just testing you.
Most important thing? Well, that's true. But I was kind of thinking of it in the perspective of like an improvement. Like, right now I'm just using a really basic 2-button mouse that came with like some old Dell. It's like standard hardware. Like you could use like one of these, I really like this Logitech mouse, if you want to, I really like this one. This is the G300S, and I'll type that into the chat if anyone wants to look into it. I love it because it's got buttons on the face of the mouse rather than the side. Because you can
also use it with your left hand. It's a symmetric mouse, right?
Yeah, this is symmetric. It's ambidextrous mouse. So this is it's a really underrated mouse. Like, costs just $20. It's wired, but I actually prefer it to be wired. So I know some people live and die by wireless, but I don't like dealing with depleted batteries. So I'll type that in the chat. So if you want my mouse recommendation, I really love that particular mouse. Yeah, it's a good point. Thanks, Modelchi. Yeah, and while I'm doing that, Danielle, did you tell him about the software you like to use?
No, I didn't. It's probably a fun thing to jump into because I think it's a given I use SolidWorks. I should probably go into what I do on a day-to-day because we talked a bit about Rob's job, but we haven't really shared a lot about mine. So I run a nonprofit. It's called the STEAM Connection. Rob is actually my design mentor. He teaches me so much stuff. I'm a very young engineering student. I have a lot left to learn. So his help is absolutely invaluable to me, and we have a lot of cool projects coming up. At the STEAM Connection, we reach hundreds of thousands of kids now. And we do this through books that I write, classes that I teach, robots that we distribute for free. Everything we create goes to kids for free. And Dassault Systems has been so supportive of this and has actually enabled me to donate way more robots than I thought possible. And of course, I designed it in SolidWorks at the beginning of 2019. My main robot, which is Every Kid Gets a Robot. Y'all might have heard of it. It's my robot that costs less than $20 and goes to kids for free. This is my really weird one. It has a fish super glued onto it as well as dinosaurs. In the process, I also super glued my hands together, which 10 out of 10 do not recommend. But this robot costs less than $20 and is sent to kids for free. I also just designed a new robot, actually with the help of Rob. Its electronics are hanging out there, but its name is 20 in honor of my 20th birthday. It was designed in SolidWorks. This is a weird decorated one. We also have this little dude here. But yeah, the kids love the bots. That's open source, free on my website if you want to check it out. It's been so much fun. You can decorate it however, and it's made out of a cereal box, which is really cool. But yeah, on the day-to-day, I write books. I answer lots of emails. I'm inventing a new project that's working on the intersection of biodegradability and robotics, which is a secret. But I just pitched it to a few people, my idea. So it's actually been like getting farther than I thought it would, which has been really cool. And I'm running a new photo series on the intersection of technology and tradition to showcase minorities in engineering. I don't know if Rob mentioned this in my intro, but I'm actually Indigenous, I'm Ojibwe. And so representation for Indigenous peoples in STEM is something that I care about so much and is something that I work towards at our organization. So be sure to check out our work if you're interested. We're always cooking up new projects. We're always inventing new things. For me, I love creating crazy things. I created most of the stuff in the room here. I drew these portraits here. This is our workshop. I drew all the circuits over here. I just love constantly creating. For my software use, I use SolidWorks, of course, have for a really long time. I love Arduino IDE, Java C++ for coding my bots. I love Adobe products, especially Audition to edit the podcast that I'm doing with my mentee, who I mentioned earlier. Her name is Vinia Gunashaker, and we run an environmental innovation podcast for kids. And we ranked number 7 in India on Apple Podcasts for education for kids, which is such a great deal for us, especially because she's Indian. It was just awesome. I also use like Premiere Pro to edit videos. Fun fact, Sean O'Neill is actually the first person who showed me how to edit a video. And the first video I ever edited was shown on the main stage last year at 3D Experience World. I was so scared. It was the first time I ever recorded like a voiceover or edited a video. I was like shaking. I remember getting up there and I was like, oh my gosh, that's my video. I didn't add any transitions. But it was a huge learning curve. And so I use a lot of different softwares on a day-to-day basis, which is probably why my computer is running like, that's a technical way of putting it. Also, as Rob mentioned, something that I'm really proud of is just like 2 days ago, I made the cover for the American Indian Science and Engineering Society magazine, which was so cool. I don't know if y'all saw that picture, but I am surrounded by robots. I could ask for nothing better in the world. But my ultimate goal is to work in biorobotics, which is the emulation of biological organisms, either mechanically or chemically. For me, I used to think I was bad at chemistry, and I hadn't really been taught it, especially with homeschooling. I've been learning it on my own lately, especially through my new invention that I'm working on, and I'm actually liking it. I'm so surprised. I used to be like, chemistry? Nah, I'm a mechanical person. But I'm proud to say I could actually move in a direction of both. And I think that's the beauty of STEM, is that when you have questions and you're curious, you can do anything that you want to. So yeah, for teaching specifically, I use the SolidWorks app for kids. I adore the SolidWorks app for kids. I've been using it forever. This was designed in the app for kids by my student named Jae-sung. I love the googly eyes. This was designed by me in the SolidWorks app for kids as an example for my students. And this is a bunny robot designed in the SolidWorks app for kids, which is a rough 3D print, but don't judge me. But yeah, the 6th graders designed those, and then they later advanced to using SolidWorks, which is really, really cool. But yeah, I mostly teach design, sustainable design, CAD, 3D printing, a lot of electrical engineering, robotics, of course. So yeah, environmental, how to recycle, all about the tech behind recycling. Yeah, I've been teaching a lot of classes now, like several days a week. So it's kind of crazy, kind of fun, and I do it all for free too. But Rob, I wanted to hop on to kind of your engineering influence, because I think that's how a lot of people know about you. I met you before that, but just seeing your work blossom is insane. I want to talk about must-haves to be an engineering influencer. Like, what tips do you have for content creators to make it, especially on Instagram?
Yeah, sure. But really quick, I just want to ask Kirby, how are we doing on time?
Oh yeah, we could talk forever.
Yeah, go for it.
Okay. So, to become like a successful influencer, I don't have any magic potion I could sell or anything like that. But
I wish.
I think if there was one thing, it's consistency. I think I had my YouTube channel, my social media pages way before 2019. And in 2019, when I started Cat Model Day, I had 120 followers. Just my close friends and people I meet along the way, kind of like that. So just posting consistently, I think, to me, I think of it as like a lottery ticket. Being consistent buys you like a lottery ticket, and I think there's also a huge luck factor. I think I was also in the right place in the right time, additionally. It's just, around day 100 is when I started posting animations of mechanical movements,
Yeah.
and people really were into that, and that's when it got to this positive feedback loop of people watching videos, people watching my animations, following, and then watching my next animation. Instagram saying like, ooh, a lot of people are watching this, let's go recommend this everywhere. And it just kind of snowballed and snowballed until now I'm almost at 50,000, which is so
It's insane.
I think it's yeah, and I looked at the chat. Yeah, Kirby did meet me when I was a SolidWorks nerd with like 25 subscribers. That was really time, and that's also what I was gonna comment on what you said, Danielle. Is like your first video ever got showed to like all those people. My first video I ever showed was like I posted it for like 6 subscribers. So it's like talk about being thrown to the wolves on on that first time. That's
I was
crazy.
I was scared. I was
Yeah, but it was amazing.
1000%
It,
scared.
it, it was a
Wait.
very impressionable video.
I know, so I'm going to bring this up because I know a lot of engineers are scared of public speaking. And so when I first started speaking, I would cry before each presentation. I'm not kidding. It was horrible. I would go in, I do like stuff in high school, chairmans for robotics, all that stuff. I'd come in and we prepared a talk and I'd just cry beforehand. I was like, I can't do it. I don't know what I'm doing. I'm bad at this. Okay. I was bad at it. It's okay. I've improved since then. But now I've been speaking in front of tens of thousands of people, and I've also been, I just spoke, I was the closing keynote at an event where Bill Gates was the opening keynote. So the point is, it gets better. It gets better. If you want to speak better, if you want to do it, you can do it. I just want to share that because I was so intimidated by it. And the truth is that the people who can pitch their engineering ideas, they go the farthest because people want a well-explained idea. And I don't know if you remember watching like the Shark Tank-ish pitches at Solidworks, 3D Experience World in the past. Presentation 1000% matters, and having those skills are important too. So if you ever need a word of encouragement or anything from like either Rob or I, because he streams all the time, his stuff is more casual. My stuff is usually more like formal, inspirational. Like, hello, you can do it. But yeah, it's been a lot of fun. I used to not see the impact of my speaking. I remember I got interrupted during one of my talks and someone was like, "You're speaking too fast." And I'm like, I don't know how to talk any slower. And then I've gone on to where I actually hear feedback from my students. And I just met a young student the other day. Her name is Sophia, and she's in 2nd grade. She interviewed me for her paper on women who inspire her. She's in 2nd grade. She has better questions than any interviewer I have ever worked with in my entire life. And she has our Doodles at the STEAM Connection as her computer background. and she listens to the podcast, and she was saying how the talks have stood out to her, and her mom was saying how my talks on mental health stood out to her. And just hearing that feedback of like, oh my gosh, I'm moving in the right direction and I'm actually making that impact that I want to, it's encouraging, because sometimes you get up there, you put yourself out there, and it's scary. So I just wanted to share that because it's intimidating, it's terrifying. It's okay, just get out there, do it, have fun conversations, do it with your friends. Initially Kirby asked me to do it, but I'm like, I'm gonna do it just with Rob. So doing things with friends makes stuff way more fun, and it's a little less scary too. So I just wanted to share that because, you know, stuff is intimidating, stuff is scary, but it's okay. Use that fear and use it to do a good job.
Yeah, I think there's a good point to be said about like really like coming out of your shell. And I think me starting my YouTube channel, especially starting streaming consistently, has helped me with that as well. But you know, another thing I wanted to mention, just kind of along the same lines, but a little different, was like, I know there's a lot of people out there trying to get their start as engineering influencers. Like a lot of them are like, you know, in the same like, you know, posting CAD models to their Instagram page. And like I said, I think I got extraordinarily lucky that one time to get the snowball rolling.
Wait, guys, hold on. He did not check his analytics for the first 10,000 followers. He didn't even know it existed. I'm so mad. I'm so mad about that, because everyone has like a formula, and he didn't even know it was there. I'm like, hey, you know that tab? And he's like, what tab? And I was like,
yeah, you could check out what kind of people watch your videos and stuff. Like you can. I'm like, you can. I'm sorry, what now? You can do what? I was just posting them and hoping for the best. Yeah,
I'm like, you got 10,000 followers doing what?
Yeah, I was like, what? It's like, it's telling me to, it's asking me to like pull up these analytics. Like, what are these? But anyway, something I wanted to mention is like, I stream 3 times a week. And if you go onto my Discord server, you know, which I can provide you the link, and I have like a share your work channel. And I basically, you know, look at other people's work and I show it off for the people that are watching the stream. So if you want more, you know, more exposure on your work, looking for feedback or other stuff like that, you know, it's a really relaxed atmosphere. Just like, you know, look at this dude. He modeled this animation and it looks fantastic. Oh, I wonder how you did that. You know, I think you did it like this. And then just kind of like, you know, working off of that. You know, I'm trying to work to like pass on my success to other people too, as best as I can. You know, because there's a lot of talent out there, and yeah, you know, it's been really fun. You know, kind of being in that influencer but also educator category.
And one thing, this is our last point. We're wrapping it up. Sound good, Kirby?
Yeah, I was going to say there's a question in the chat from.
Oh, there is. I don't have my glasses on, so thank you.
I started using Solidworks last year and I really like it. Although I do not use it for my work, I would like to volunteer for a non-profit organization that develop projects using Solidworks that accept volunteers with non-experience. Any suggestions?
This actually is a perfect segue into what Rob and I are going to be talking about. Like, could not have asked for a better question myself.
Excellent.
So I'm going to bring up a project one that Rob and I worked on. I talked a little bit about the 20 robot, the one that looks like Furby got put in a shredder. I did not mean to design it like this, but yeah, it's made with a cereal box. The kids love it. They get to decorate it, get to play around with it. But Rob and I actually designed it together, and it was inspired. We wanted to replace ball casters, so just yeeted it off the ground. We were inspired actually by paint rollers, and I remember calling him up one day, and I was like, "Hey, I want to replace a ball caster with a paint roller," and he's like, "What?" And I was like, "A paint roller," and he's like, and I'm like, frame and bead. And he's like, "What are you talking about?" And I remember trying to pitch it to my mom too. She's like, "What?" So together and with his help, I was able to get 20 to happen. And we learned a lot in the process. Do you want to talk a little bit about the design of the cap quickly?
Yeah. The cap. Yeah, of course.
Yes.
And you know, I just wanted to like make a quick comment. It's just like you know, you hit the nail on the head when you said, you know, the people who can articulate their ideas get the best. I love your hat.
Thank you.
gets the furthest, and that is absolutely the case. And that's why I love SolidWorks so much. Like, it's one thing to, like, show up to some like investor's office or to some investors and then slap a stack of papers and like, in here is the next big thing for like renewable energy or something like that. And they're like, he's gonna look kind of like, I'm sorry, what? It's just 2D drawings. You have to be trained to read them.
You got to be able to communicate it.
Got to be able to communicate. And that's like what SolidWorks helps so much. It's not only like oral skills of like being able to give a presentation,
Imagery.
but it's also imagery too. Like, you could, with an SolidWorks animation, that'll bring it to life, render it and visualize, make it look realistic. That'll like make the spark go off. Like, yeah, that is the next thing. Here's a check for $1 kajillion, make it happen, or whatever.
Okay, may not agree with that one, but it's
I'm sure it happens that way. Like, $1 kajillion.
As someone who has to fill out lots of grants, I have to say, unfortunately, it doesn't work that way. And filling out grants is horrible. If you're thinking about starting a nonprofit, get a volunteer who can write grants for you, or you're going to be sad.
Good advice. But up until that point, being able to communicate is just really, really helpful. But
and quickly just share a little bit about the CAP, and then I'm going to go into the volunteering.
Oh yeah, the CAP. I basically use a sheet metal engine. I kind of cheated in SolidWorks where I actually modeled how I wanted the hat to look like as like a solid cube, and then I used the convert to sheet metal function within SolidWorks to actually generate the bends. And from there, you can get a flat pattern, which you can print out, trace out on a piece of cereal box, cut it out, and then fold it up, and it's great.
And the reason why it happened this way is because I didn't have my software at the time, so I was like, help, help, help. So what I did is I didn't have, the software didn't renew. So I was like, I'm going to design it just out of cardboard, no computer. So I just started folding cereal boxes. I hold up this really janky looking thing. I'm like, let's CAD it. Rob's like, what? And I'm like, we're gonna CAD it. And then I remember I like flatten it out. He's like, what? And then I sketch it out in paint. I'm like, this is how it's gonna look. And he's like, okay. But it's been a really fun process. I have learned so much from him. But to hop into the volunteering and stuff, him and I are launching a new project for youth. And it's called Bringing Recycling to Life. And it's real life CAD applications for kids through cereal boxes. So basically, we're going to be posting CADs and videos about different CADs and ways that you can recreate it by folding up cereal boxes instead of 3D printing using plastic. So that is our concept behind that. We're going to be launching it through the Steam Connection, Rob and I. And if you feel like that suits you and you want to volunteer for this project, go to our website it's in the chat. We have a volunteering page. You can volunteer to be a 3D printer. You can volunteer to join our team. We're always looking for people who can help us reach students and who want to learn in the process, especially if you want to learn from Rob, because he is doing such a great job and the work that he does is absolutely amazing. So yeah, we always are looking for volunteers. We're always looking for support. And we're always looking for people who are engineers and who can help mentor, especially my young students. We have a lot of young Indigenous students, especially. We're founding new programs, and we can use support in that, and we can use help. So if that sounds like you, email us, check out my website, whatever, contact Kirby, he'll forward it, whatever you want to do. But yeah, thanks so much for attending and kind of hearing us ramble on and chat about some of our past experiences. I wanted it to be super casual. I think that it's a lot of fun. And if you have any questions too, we can answer those before you leave. So yeah.
Yeah.
Excellent. That was fantastic. Just to add on to Louis' thing, you can also check out any local makerspace. Because they also have a lot of kind of educational kind of courses and that stuff, learning how to use their stuff, their equipment. So if you can get really involved with them, you can help them teach people who don't know how to use SolidWorks and any other kind of engineering equipment, laser cutters, 3D printers, all that kind of stuff. So
it's so much fun.
Yes. That was really interesting. I enjoyed that. Thank you very much for just having just listening to you guys chat is always really awesome. Like I said, I've known Rob since he was Solidworks nerd. Didn't have many followers or anything. Kind of still figuring out what your angle was going to be. But model of the day, it's fantastic, and it's really you've stuck through it, and it's a lot of I think about making one model. I'm like, nah, tomorrow I'll play some Minecraft instead.
I feel that.
And Danielle, like you always seeing you being featured on on different TV shows and magazines, and being featured with L'Oreal and all that stuff. It's always inspiring to see how much you're doing, and I don't know where you get the time to do all of that, because like I said,
it's called Red Bull.
I try that, but when I have to make one model, I'm just like, no, I don't really want to do that tonight.
I can feel that. I feel that. No, there are some days I do absolutely nothing, and that's okay. I've tried to learn the work-life balance. The life isn't really there yet, mostly just the work. But at least I enjoy my work. But I have to say, for like the sake of mental health and stuff, like take time off if you need it. Tell your boss you can't come in. You don't have to be there every day. It's okay. Do not. I'm my own boss. I need to tell myself that. I'm like, girl, do not answer any emails today. It is okay. Yeah, I just want to say that because, oh my gosh, it's a lot. It really is.
My boss has to reduce his time to 3 days a week because his son doesn't recognize him.
Oh gosh. But something I will say,
it's kind of funny, but it's sad at the same time.
That's definitely sad. Yeah, everything being virtual here, I have a feeling everyone knows each other way too well. Way too well. I live with my family. That's enough said.
They're roommates. You call them roommates if you still live with your family's your roommates.
Yeah.
Yeah.
Exactly.
Yeah.
I have a 5-year-old that I live with. He's my coworker. He just happens to.
Oh.
There you go.
Yeah.
I'm sure he's really helpful in the design process.
Yes. I have had him on Apps for Kids a couple times, which is it's amazing to see that, like a 5-year-old, because he's grown up with touch screens and that mindset. It's just
they're faster than us. I didn't grow up with touch screens. Oh my gosh, it's so cool.
Yeah, it's crazy. It's awesome. Yeah, Danielle, Rob, that was awesome. It was a great conversation.
Thanks. Always fun to chat. We've missed you guys.
Yeah, for sure.
Then I want to comment for that Helix design. I got so caught up with it that it was almost going to be like my challenge for the rest of the month.
Yes.
But I managed to create it with only 2 features.
Wow.
Wait, really?
I gotta see it. That's awesome.
You should show us, or at least DM me, and I can put out my story.
I cannot share my screen, but I can tell it. You can create an equation-driven 3D sketch to create a helix.
Oh my gosh.
I guess so.
That's awesome.
I see that.
Wow.
You see, this is the kind of stuff I praise, and I don't think gets enough attention, frankly. That's awesome. You know, that's what at least when someone has that aha moment, you know, in my community, I hold them up. I'm like, look at this amazing thing this dude or this guy did. You know, it's awesome.
And if y'all don't know who Eggman is, he's always having those aha moments. I don't know if you've seen his Instagram page, but I text him about even just like simple ideas, and he comes up with the craziest things, and I'm like, why doesn't my brain work like this? It's not fair. But he comes up with the coolest stuff. Check out his Instagram.
Now I'm gonna have to edit that quiz, Eggman. That's awesome. I would love to see the model, and Rob, I think we found your next model of the day. You know, if it's on.
Send me a picture.
Yeah, I haven't decided one's gonna be, but that's a good candidate.
Yeah, that's awesome. That's cool.
And he takes like suggestions too. Rob does.
Yes,
because he's running out of things. He's like, Danielle, what do I do? And I'm like,
honestly, these days I am actually spending more time trying to come up with something I haven't already done yet. Because my goal is to like make them all.
Catting it.
But after 530 days, it's starting to get kind of hard. So
sure.
Like, oh my gosh, I already did a ring light. Damn.
Yeah.
I have an idea for you.
Yeah.
One thing I struggled once was I was trying to create something like a chair or like a stool from a CNC machine. But I wanted to assemble the stool in kind of like a loft or an extrude but twisted.
Yeah.
And I wanted to be in 2D sections. So splitting them and creating creating the surface from using convert entities is very unpractical. And I've tried using slicing, and it's only introduced in Solidworks 2019. So you can use fake curves for that as well. And if you import or convert all of the sketches into one 3D sketch, and then if you extrude it, you can extrude all of them at once. So it's very quick to do it that way.
Wow, that's pretty interesting. I'm gonna have to play around with that. That's so cool. I'm writing that down. That's really good.
You've got the best ideas, Ivan. You always do.
By the way, just a new development. I became CSWE of both mechanical design and simulation.
Awesome.
And simulation as well. That's
great.
amazing.
That's hard
Wow.
to do. Yeah.
Super congrats to that. That's awesome.
Thank you. Fun fact,
my
I
gosh.
got
So
full
good.
score in CSWE mechanical design, finishing it an hour and a half early.
Wow. Amazing.
That's amazing.
I know some people in my community would love to meet you. So, just
Same with mine.
hang out
You need to come teach a
sometime,
class.
Very cool.
Yeah, amazing.
Is that Loki, Kirby?
He just woke up from a nap, so.
What a cutie. Unfortunately, I can't bring my cats to the workshop.
Too much hair.
Yeah, and they'd eat everything.
That handle?
Yeah, it is.
Okay.
I like how I just answered for it.
Yeah, I'll take your.
Like, yep, I knew it already.
I'll take anyone's word for it.
I mean, that's been a fantastic, unique user group, open conversation, and Dan giving some tech tips. Shout out to Dan. Dan and I matching T-shirts. Totally not planned, but it happened.
We called each other. It's fine. We can, yeah.
Thank you, Dan, for arranging the quiz and the gift vouchers.
Yep.
I've sent you the email address of the winners and that, and we'll organize with Oscar about the if there's a charity option. We can figure that out.
Cool.
There is like I was saying, there's a new user group in the UK now, run by Johnny Harrison, who's in here earlier. I'm going to paste his user group in the chat if anyone wants to follow him. He's looking to arrange his next meeting real soon. So that's northeast of England, near Newcastle way. So it's awesome. We are spreading the user group network around Europe, which is exciting. More and more showing interest and more popping up, which is excellent. Can't wait to start running them in person again.
Yeah.
Have dinner and pizza, hang out.
I've been missing everyone so much.
Yeah, I was gonna kind of ask that same thing. Is what, or in reference to that, is what are things like in the UK right now, Kirby, in terms of things being open, and what does the future look like?
We've just started very slowly opening things up. So, for example, non-essential shops and restaurants and pubs with beer gardens are open.
That's
so
good
news. They're opening things up very, very incrementally, and it should be only around June when things are opened up properly. So maybe by the end of the year, we'll be able to do a in-person meeting. If not, I'll save it for next year, either before or straight after World.
Awesome.
But so on my meetup page, we've got Slug Me 6 booked in there. The dates have changed to sometime in August. I need to confirm the dates.
August 21st.
We'll be participating August 21st.
Yep.
We'll be participating in SlugMe, which SlugMe stands for Solidworks largest user group meeting ever, which has now been changed to Solidworks longest user group meeting ever, where it's going to be a full 24 hours of Solidworks user group meetings all around the world, running from a Saturday night here in the UK, I think 5 p.m., going all the way to Sunday evening 5 p.m. Every hour a different user group meeting is happening. So I'll be hosting one, presenting design for 3D printing. So if you're interested in hanging out for that and just following along where it is, it's being run at the exact same time as the Le Mans race in France. So it's they're going with the whole drivers pit crew kind of theme for it. So I'll be posting more information about that one. I'll swap out the June 12th for a different presentation. I'll find something else that will be interesting to show off. And I think that's a good place to wrap up tonight's meeting. It's been fantastic. Thank you very much for presenting, and thank you very much for everybody who's joined in. This has been recorded, and it will be put online in the next couple of days for anybody that has missed it.
Okay.
Thank you. Thanks for having us.
Cool.
Thanks
Thanks
again. Thanks for having us.
Thanks, everybody.
Bye.
Take it
Nice
easy.
meeting. Thanks for everyone.
See ya.
Good to see you.